In the very interesting subject computer organization and architecture, we are going to discuss about the shift registers and their universality. The shift register is a very important operation, and it is a beautiful circuit which has been designed by earlier mathematicians and scientists so that in binary system we are able to shift the data. Dear friends, as we well know that ALU is a circuitry and it is responsible for arithmetic logic operations. But basically the full form is ALSU, where A is for arithmetic operation, L is for logical operation, and S is for shifting operation. So in arithmetic operation, the adder, subtractor, complementary adder, query look ahead adder, binary multiplier, array multiplier, and division algorithms are included. In logic operation, there are 16 possible operations where we apply all the 7 gates AND or NOT, NAND NOT, XOR and XNOR, and with the combination of them, we can apply the selective set, selective clear, selective complement, and insert and all clear, all reset, all set operations on the binary data. The othermost operation is the shift operation, and shifting is basically of mainly 3 types. So here we can include as logical shifting, other one is circular shifting, and third one is arithmetic shifting. And there are left and right shifting possible. So as per that, left logical shifting, right logical shifting, left circular shifting and right circular shifting, and left arithmetic shifting and right arithmetic shifting are possible. So here we proceed that a shift register is basically a bidirectional circuit where we can together shift left and right both. As well as to enhance the capability, it may be possible that we can load the data as well as add the additional facilities by multiplexer. The multiplexer, we know well that multiplexer is a circuit where 4 possible inputs are there and 1 output is there. So input versus output. And there are 2 selection lines. So as per the values of selection 901, 0001, 10 and 11, we can apply the load operation and right shift operation, left shift operation, and parallel or complement operation or clear operation. So here, my dear friends, we can see that with the help of multiplexer and the binary inputs, we can apply technically in a very better way about the bidirectional shift register. Before starting the shift register, let us understand that they have a wide range of application. They are used in the computer and data communication, converting between serial and parallel applications, multi-bit number storage application, sequencing or designing of the enabling system, basic arithmetic operations, because we have a binary system. So in conversion of binary number to the decimal number, shifting can be done, and logical operation, delay circuits generation, state machine operation, parity circuit generations, and many more applications are possible with the help of shift registers. In serial communication, as we see that whenever from the sender to receiver side 10110 is being transferred to the receiver, then they are being shifted in parallel mode. We are being transferred into the parallel operation. Means all the bits are in one go transferred to the other storage space. Now shift registers are very simple, like data is 10110 and when it is right shifted, then it is shifted by 1 bit. So an external input IR is being provided. And we can see here that 0 is shifted to this, and 0 is discarded. It will be lost from us, and 1 is shifted here, this 1 is shifted here, this 0 is shifted here, and this 1 is shifted here, and IR is shifted. So one IR external right input is being inserted here. So in parallel shifting, or a combination of serial and parallel shifting are possible. So here you can see that a shift register is designed with the help of flip-flops because flip-flop can store one bit of information. So shift registers are constructed with the different flip-flops. It may be edge-triggered devices flip-flop or output state retention flip-flop. Each binary digit transfer operation requires a clock edge. Asynchronous inputs are useful in resetting the whole configuration. So to generate the synchronization, we have to keep the clock pulse same, and if the clocks are different, then they will generate an asynchronous operation. So shift registers are comprised of D flip-flop because D flip-flop has property that whatever the input is given, the same output is obtained after applying the clock pulse. So if input I is given, then the same input I will be obtained as the output. So in first clock, this if in this 101 is being applied here, and if we see that 1 is being applied here, 0 is being applied here, and 1 is being applied here, then in the second clock, this 1 will be being out as the output. Then in other clock, this 0 will be shifted here. In the same clock, this 1 will be shifted here. In other clock cycle, this 1 will be extracted out and 0 will be pushing to this. This 1 will be pushing to this, and external input, whatever IR is being transferred from here, will be pushing to these bits. So we can see that if there is 101, so in first clock cycle, we shall get 101 as the output. In second clock cycle, this one will be discarded and there will be 10 and IR. In third clock cycle, we can say in third cycle, we will see that IR will be shifted again and this one will be remaining. In fourth cycle, this IR and IR. Trail mill will be there. So as per the operation, there are four possible shift registers: serial input and serial output. Serial input, parallel output. Here you are getting serial input, and one by one, all the outputs will be transferred in serial input, serial output. In serial input, you are giving input here, and all outputs are getting parallel in one go. So it is CPO. And PISO, parallel input, serial output. And in PIPO, parallel input, parallel output. Now I am much interested to design serial input, serial output. So in this diagram, you can see that this is the clock pulse, which is synchronous because it is being applied same here in all the D flip-flops. So whenever the data is being transferred here, so 101, so in first clock, this one will be here. In second clock, this one is going here and 0 is being shifted here. In third clock, this one will be shifted here. This 0 will be shifted here. And this third one will be shifted here. So you can see that in first clock, this one will be here. In other one, this 1 and 0 will be here. And a third cycle 1, 0, 1. And then external input can be given. So after 3 clock cycles, 101 will be stabilized as the output. In serial input parallel output, this is the clock which is being applied here. And whatever input you are giving here, the output is taken back parallelly at all the destination points. So if 1 is giving here, so there will be no output, there will be no output, and 1 is coming as output here in first clock cycle. In other clock cycle, if the same one is being, chain of 1 is being provided, then the 1 is shifted here, another 1 is shifted here, again 1 is given here, so then 1, 1, and 1 we are getting as the output. So it is giving you parallel output in all the flip-flops. In parallel input serial output, a particular logic is being applied and the inputs are giving you parallel and we are getting one output one by one. So one by one output are being obtained. And in parallel input, parallel output, you can see that three inputs are being applied and at all the flip-flops we are getting output. So this is parallel input, parallel output operation. So these are the four possible combinations of the shift register, and in shift direction is very much important whether it is the left side or the right side. Parallelism, it is sequential or parallel. We have to take care also. And whether we have to hold the data at the same position or we have to get it moved, we have to take care of all these four parameters. So here, shift register is obtained in form of a IC74LS194, and this IC is ready-made available as an embedded system and helps us uh, to apply the shifting operation in different possible combinations. So here you can load the data. Then at 0, 1, you can apply the right shifting. At 1, 0, you can apply left shifting. And at 1, 1, whether it is complement you want to do or you want to all clear the data. So now at the workspace, I'm going to make a shift register for you. So suppose we have two possible selection 0, 0, 0, 1, 1, 0, and 1, 1. So we have operation possible loading of the data, right shifting operation, left shifting operation, and we want to do complement of our data, which can be used in other operation. So for this, we will take 4 multiplexers, each of 4 by 1 configuration. So these are 4 by 1, 4 multiplexers. There are 2 selection lines in each multiplexer, S1, S0, S1, S0. So I'm understanding that all these selection lines are being passed parallelly to all these multiplexers. Now, there are 4 inputs which are possible to be given into each multiplexer, and we will do connections one by one. And there will be 4 outputs, one from each multiplexer. So 4-bit output we shall get. So here our actual data is A3, A2, A1, A0. It is a 4-bit data. After right shift, we will get IR A3, A2, A1. And after left shift, we will get A2, A1, A0, and IL. Where IR is external right input, which is given from the external body from the right side. And IL is the external left input, which is given by the external body for the left shift. Now at 0, 0, this is 0, 1, 2, and 3. Now at A3, A2, A1, A0. We have to make all the combinations very clearly. A3, A2, A1, A0. It will be get obtained from all the 0 first selection. We will get all the load data. Now at 0, 1, right shift we want to do. So we want to get IR. A3, A2, and A1. Then at 1, 0 combination we want A2, A1, A0, and external input IL. And here we want complement of each. So at 1 we will complement of each data. So it is a binary bidirectional shift register which is having the four possible capacity. At 00 we will have a load operation. At 01 we will have right shift. At 10 we will have left shift, and at 11 we will have complementation of the data. So I, Dr. Rohit Rastogi, welcome you all from ABES Engineering College, and we are sure that in next time we will learn to make a separate circuit, and it will be very interesting and useful for you. Stay safe and stay blessed and keep connected. Thank you very much, and bye bye.